I thought what I'm going to do is a short video on how that carry bit works in the Rockwell Automation PLCs. Some of you have answered the discussion topic. Some of you understood and found the information that is correct in how it works. Some of you have not. So let me do a demonstration of how this carry bit works for both the add and the subtract instructions. The carry bit is not valid for multiply and divide. So I went to the Rockwell Automation website and logged into their knowledge base. You know, in the past week, I've got to tell you, they've locked out people that do not have a Tech Connect license from activating or accessing their knowledge base, which I think is really stupid. So if you logged in and tried to get information, you know, even 2 or 3 days after I made the assignment, you would no longer be able to access the knowledge base. So let's take a look at it. And when you go to the knowledge base, you'll find that there's 2 equations for determining when the carry bit turns on. The first one for the add uses this equation, and the second one for the subtract uses this equation. And I changed the designations from what Rockwell used in their knowledge base, where MSB is the most significant bit, and I used a little a to designate that it's the most significant bit of source A. I use a little b for the most significant bit of source B, a small d for the most significant bit of the destination. These in parentheses are logic functions. The and sign is a logical and. So it takes MSBA and MSBB. The pipe symbol, which is the vertical line, is a logical OR. So it takes this set of parentheses and ORs it with the results of this set of parentheses and ORs it with the results of this set of parentheses. And this little squiggle character is a logical NOT. So it's an inverter. So let's take a look at an example. And I'll be using the SINT data type for the examples just to make it easier. And let's take 2 plus a minus 1. And when we do 2 plus a minus 1, we should get 1 as an answer. Now this particular example does generate a carry. Remember I told you, under the hood, everything is in binary. And when it's doing addition, it's doing binary addition. So let's convert all this to binary. So 2 is 0, 0, 0, 0, 0, 0, 1, 0. Remember, SINT is only 8 bits. And negative 1 is 1, 1, 1, 1, 1, 1, 1, 1. And we're going to add these. So 0 plus 1 is 1. 1 plus 1 is 0 with a carry of 1 because it's 2, and so it's a 0 and a carry of 1. 1 plus 0 is 1. 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1. 1 plus 1 is 0 with a carry of 1. You can see that that's going to pretty much follow through. So we're going to have zeros, zeros, 0. That's carried 1. 1 plus 0 is 1. 1 plus 1 is 0 with a carry of 1. None of these carries are what turned on the carry bit. What turned the carry bit on was when a 1 got carried outside of the valid range of numbers that the data type can hold. So SINT can hold the valid numbers are minus 128 to plus 127. Anything less than 128, anything more than 127 can't fit in a SINT. In this case, that 1 got thrown off outside of the range and the carry bit turns on. Let's take a look at the same problem, and this time we'll look at the equation that Rockwell gave us. So here is source A, here's source B, and here's our destination. And this is the most significant bit. So let's take a look at this first expression. It's the most significant bit of source A and the most significant bit of B. So the most significant bit of A is 0 and most significant bit of B is 1. Well, this is an AND function. Anytime we have a 0, the output's going to be a 0. So we know that this one is 0. And then it's going to get ORed with the not of the most significant bit of the destination. Well, the destination most significant bit is a 0. We're going to not it. We get a 1. And we're going to AND that to the most significant bit of source B, which is a 1. A 1 and a 1 is a 1. I don't even have to go any further if I don't want to, because I'm going to be ORing this function. And a 0 or a 1 is going to be a 1. And any time an input to an OR gate goes to a 1, the output is going to be a 1. But let's continue through just to prove that. So we're going to OR this with the not most significant bit from D, which is a 1, and the most significant bit from A, which is a 0. A 1 and a 0 is a 0, and these are then ORed. That's a little difficult to tell the difference, but 0 or 1 is 1, 1 or 0 is 1, so we got a carry. So it proves that the carry bit did turn on. Now, in the discussion, some of you said, it only turns on if I have like 2 negatives. Well, that's not necessarily true either. If I take the values, let's try another example here. So if I do the number of 127 and I add 3 to it, well, 127 plus 3, when I do this addition with the PLC, I'm going to get a minus 126 as the result. Well, we know darn well that that's not the solution to 127 plus 3. The real solution is 130. However, 130 will not fit into a SINT data type. So this is going to throw an overflow, but it is not going to throw a carry. And let's prove that. 127 is 0, 1, 1, 1, 1, 1, 1, 1, and 3 is 0, 0, 0, 0, 0, 0, 1, 1, and we're going to add these. Well, 1 plus 1 is 0 with a carry of 1. 1 plus 1 is 0 with a carry of 1. 0 plus 1 is 1. 1 plus 1 is 0 with a carry of 1. 0 plus 0 is 0. 1 plus 1 is 0 with a carry of 1, 0. This is 0 with a carry of 1, 0. 0 with a carry of 1, 0 with a carry of 1, and 1 plus 0 is 0, 0, 1 plus 0 is 1, and 1 plus 0 is 1. I did not get a carry outside of the range, and my number did come up negative. Take notice, the sign bit is set, and if you go back and do the calculations, this would be equal to my minus 126. So let's take a look at using the equation. So here is the most significant bit of source A. Here's the most significant bit of source B, and here is the most significant bit of our destination. And let's use the equation. So the most significant bit of A is a 0, and the most significant bit of B is a 0, and I get a 0. And then we're going to OR these. And we're going to OR it with the not most significant bit of the destination. Our destination is 1, not that is going to be 0. So I already know that this is going to be a 0, because anytime an input to an AND gate is a 0, the output's a 0. But let's continue on. The most significant bit of source B is a 0, and that is a 0. And we're going to OR this with the not of the most significant bit of the destination, which is a 0, and the most significant bit of A, which is a 0, and I get a 0, and 0 or a 0 or a 0 is a 0, so therefore I do not get a carry, which proves out there is no carry, but I did get an overflow. So that's how the carry bit works for the add instructions. So anytime I get a carry outside of the range of the data type, it'll throw a carry bit. Now, while I erase this board to make some room, let me tell you what the carry bit is used for. Because the carry bit is a leftover from when PLCs were only 16 bits. And when you had to do 16-bit calculations, it was very easy to get numbers that were outside of the range that could be held in 16 bits. If you think about it, I can only have 32,767, and I could very easily get numbers outside of that range. So what the carry bit did was it allowed people to do 32-bit math with a 16-bit processor, so that when the carry bit turned on, you could assign another word to the upper word and start to do 32-bit math. So that's what it was intentionally used for. Since most PLCs today are 32-bit, we don't really need the carry bit anymore. I used this exercise to have you learn how to get out there and do some research on items when you don't know how they work or you don't know why something happens. So let's now look at the subtract example. We'll look at two subtract examples. One that's going to, actually they're both going to throw a carry, but one's not going to throw a carry during the binary part because you're going to need to use the equation. So let's take a look at an example of a subtract. And let's take a minus 100 and we're going to subtract 5. And that's a plus 5. So when we do that, we're going to get as an answer minus 105. Now minus 105 will not throw an overflow because that'll fit in a cent, but it is going to throw a carry. So let's look at this in a binary format. First of all, 100 is 1001 1100, and 5 is 00000101. And we are going to subtract. Now, I never taught you how to subtract in binary, so let me do a quick little lesson in subtracting in binary. I have a 0 minus a 1. I can't do that, which means I have to borrow a 1 from the previous, or from the place to its left. Well, I can't borrow a 1 from here because that's a 0. But I can borrow a 1 from this place. So I'm going to borrow a 1 from here, which is going to make this a 0. When I borrow a 1, this becomes 10. Because I'm borrowing actually the weight value of 2. This is base 2. When we carry in decimal, we're carrying 10, which is the base. So now I've got to borrow another one from this 2, which is going to make that a 1, and this is going to be a 1, 0, which is a 2. So 2 minus 1 is 1. And then 1 minus 0 is 1. But here I have another 0, so I have to borrow 1, which makes this a 1, 0. And 2 minus 1 is 1. And here I have to borrow another 1, which makes that 1, 0. So 2 minus, no, I didn't have to borrow. My mistake, totally. My total mistake. 0 minus 0 is 0. 0 minus 0 is 0. 0, 0, 1. If I didn't make any further mistakes, this should be minus 105. But I wanted to show you that I did not have to borrow 1 from outside of that range. However, when I use the equation for the subtract instruction, the subtract instruction, my most significant bits are right here, and that's for A, B, and C. So not most significant bit of A is going to be a 0, and most significant bit of B is going to be a 0. So 0 and 0 is a 0. And then I'm going to OR this with the most significant bit of the destination, which is a 1, and the not most significant bit of B. B is a 0. It's going to become a 1. 1 and a 1 is a 1, which means I'm going to have a carry bit, and we'll just finish it out. MSB of D is a 1, and a MSB of A, which is a 1, which means I got a 1, and 1 and 0 is a 1, which means I do get a carry bit, even though I didn't see it when I did the math side of it. So using the equation, I did get a carry. So let's show you another example where I'm going to be using and can see the carry bit. Let's do 5 minus 28. 5 minus 28 should give us a minus 23. And this is going to cause us to create a carry. So 5 is 0, 0, 0, 0, 0, 1, 0, 1. And 28 is 0, 0, 0, 1, 1, 1, 0, 0. And we're going to subtract. This time I'm going to do the subtract and try not to make a mistake so you can see it a little bit cleaner. So we can take 1 minus 0, which is 1. 0 minus 0 is 0. 1 minus 1 is 0. But here I have a 0 minus 1. I can't do that. I'm going to have to borrow from the next place. Well, that's a 0. I can't borrow from there. That's a 0. I can't borrow from there. I can't borrow from there. So I've got to borrow a bit from outside of the range. I already know that I'm going to get a carry. So this becomes 1, 0. Now I can borrow a 1 from this to here. So this becomes a 1. This becomes a 1, 0. I can now borrow from this. This becomes a 1. This becomes a 1, 0. I can now borrow from this. This becomes a 1. This becomes a 1, 0. I can borrow again. This becomes a 1. This becomes a 1, 0. So 2 minus 1 is 1. 1 minus 1 is, I'm sorry, 1 minus, 1 is 0. 1 minus 0 is 1. 1 minus 0 is 1. And 1 minus 0 is 1. And that should be equal to minus 23. We'll use the equation. The not MSBA, MSBs are, let me change color here to see if we can see it easier. So this bit and this bit and that bit. So we've got MSB of A, the not of it, which is 1, and MSB of B, which is 0, which is going to give us a 0, and we're going to OR that with the MSB of the destination, which is 1, and the not MSB of B, which is going to be a 1, and there's our carry. And we're going to do a MSB of the destination, which is 1, and MSBA, which is a 0. That's a 0. But a 0 or a 1 is a 1, and a 1 or a 0 is a 1, and it proves that we've got a carry. So that was a lot of math to show you that the carry bit for a subtract, you can sometimes see it while coming into the math, but if you use the equation, it'll always determine whether or not the carry can get thrown. I hope you read the note up front, because I'm pretty sure there was an error in the Rockwell's knowledge base for this, but I hope this explained it to you. And I'll see you around.